This is my drum sander. It's not the fanciest model on the market, but it gets the job done. I've got no real complaints about it, except for the stand. So what's wrong with the stand? Well, it's made from thin sheet metal, like a lot of these sort of tool stands are, and they're okay at best. It's a little bit flimsy, but there's a lot of dead wasted space that I could store something on, like the rolls of sandpaper that go with this, or something at least, but there's no real way to add shelves to it. It's just a big pain. It's a little bit too tall as well. It doesn't match up with any of the workbenches or outfeed tables I've got. So it just sort of floats around. It's awkward to use. And the next problem, unfortunately, I can only blame on myself, is the mobile base. When I got this, I needed to make use of it straight away, and I didn't really have time to fiddle with the mobile base. So a piece of wood, some much too small casters for the weight, and that's all it is. So this is really terrible for the weight of the machine. These are only 50mm 2-inch casters, though they just don't work very well, particularly on the rubber flooring tile. Something has to be done about that. Now, I have actually used this design before. The stand itself was just slapped together at the time, but it works really rather well. So I've somewhat formalized it into a parametric design that I can reuse on other things. So having just a basic plan that I can default to means that I don't have to overthink stands unless they really need something specific on them. So having a look at this model, it is fully parametric, so I can change, let's say, the target width, and it changes all the dimensions that are necessary. There are really just these few parameters here to change. The material width, so I'm using a 90 by 35. The other option would be like a 70 by 35 or a 90 by 45. Those are the standard construction grade sort of stuff. Pine here. The target height is what I want at the top of the table of whatever machine it is. So if it's a spindle sander, I want the cast iron table to be that particular height. For the drum sander, it's going to be the conveyor belt. The caster height, so I've got 5-inch wheels. So 127mm. The tool table height, so that's from the base of the tool, where it's going to be mounted up to the top of whatever that target height was. So in this case, that's going to be 90mm. That's from the foot to the top of the conveyor belt. Width and depth are fairly self-explanatory, and I'm just using a 3mm piece of MDF. There are other parameters, but they're not overly important. They're more the calculated values. The only one that is interesting is the total linear meters, or total linear material needed, which is just everything added up. It's not necessarily going to give you a cut list from that, but in this example, I need at least 6 meters of material, so I can tell when I don't have enough. From that, I can generate a drawing, take that to the workshop. Unfortunately, it doesn't seem like that is something I can easily export and share with Fusion 360, so for now, we can just ignore that that exists, but that's what I'll be basing everything from. None of the joinery is added to this because there are so many options. You can use dominoes, dowels, loose tenons of other sorts, integral tenons, half flaps. I wouldn't use pocket joinery for this because of the forces of a heavy machine. I think the drum sander is 70 kilos. I don't really want to trust that to pocket screws, which aren't the strongest for this sort of application. They're not going to resist the racking forces, whereas proper joinery will. So I would encourage you to use dowels over pocket screws or any other method of joinery. I'll have a list to a whole bunch of power tool mortar tenon videos up in the corner. This is a really simple build, really only needing the miter saw to cut things to length, then whatever joinery you're going for. I've opted to also dress everything, mostly so it looks prettier, but it will also make joinery easier too. Everything gets jointed one face and one edge, then run through the thicknesser to square up the opposing edge and face. So I've got the leg piece in the vise, I've got my dowel jig, drill, and some dowels. I'm ready to actually drill into this for the joinery. Though I wouldn't actually recommend this setup. This isn't a dowel and jig, it's for some knockdown bolts. This isn't the workpiece, it's an offcut. And these aren't dowels. They're breadsticks. Since I unfortunately don't have a doweling jig, I've had to force myself to use the Domino. Again, there are plenty of alternatives, but this is meant to be a quick design for me. The two large rectangular frames get 4 6mm dominoes at each joint. Overkill perhaps, but it's still quite quick to put in. Glue up does become a bit of an issue with so many dominoes. There is just so much friction when using a water-based glue like PVA, but as liquid hide glue is a bit more expensive, it doesn't get brought out for shop fixtures. I got all of the joints started with the mallet, but as part of my review process for these clamps, I use them to cinch everything shut. These have a claimed 7,000 pounds of force, which is a tad too much for anything I do, but maybe I won't actually need to make mortises in the future. I can just use these clamps to force a tenon into a piece. On the short sides I added a shallow rebate at the router table. I forgot to do this on the other parts before glue up. Just like all other parts, the short pieces are also dominoed in. So I'm adding a plywood top to the cart, and that's definitely for aesthetic reasons and not because I measured everything basing it off my new outfeed table without leveling the feet. Definitely aesthetic reasons for the plywood top. That's the story we're going with. The MDF panel is glued and nailed in. Despite being just 3mm thick, it will still provide a lot of rigidity against racking. So this is about where I want the drum sander to actually be used at. This is a great height with the outfeed table. For whatever reason, I didn't calculate the height of the casters correctly, and I didn't account for running all the pine through the thicknesser. So cumulatively, I was out a little bit more than I should have been, but some spaces underneath the feet of the drum sander account for it. And this is fantastic compared to the old metal stand where I couldn't get this close to the outfeed table because of the A-frame design. If I did want to add some additional rigidity, I could add in a panel at the back here like I have done for the sides. It would really make it a lot more secure, but that being said, this is still rock solid. One of my complaints with the original metal stand was that I didn't have any additional storage underneath it, so it was really dead space. Just the frame itself being a little bit wider allows me to store my small compressor here, and because it's wood, I can just screw in cleats on the side for a shelf. I can also screw in just drawer slides directly into the pine, and I think that's the way that I'm going to go. Then I can have a little tray with all the rolls of sandpaper and the eraser to get rid of all the gunk on the sandpaper. So I think that's what I'll do now. The tray construction is nothing exciting, so much so that I forgot to hit record. The sides are some 19mm offcuts with a dado to capture the base. Glue with brads to secure it. The clamps are just there to hold everything in rough position. The drawer slides are screwed into the side of the drawer, then the mating part is screwed directly into the frame. I used an off-cut spacer to position how far down I wanted the drawer slide. In hindsight, I should have made the spacer how far up I wanted it so that I wasn't fighting gravity. frame is super sturdy. It's got some inbuilt storage. The tool is at a much more comfortable height. I'd say this was a fairly good success despite my attempt at sabotage by not reading numbers correctly. So I've used this a little bit for small stuff. It's fantastic being able to just let it fall onto the out feed table. For longer stuff, I do need to have a little bit of additional support. I've just been using rollers. That works great for the larger stuff, but maybe I'll have some swing up out feed support, but I haven't decided exactly what that's going to look like. The parametric model for this, which means you can expand it to any size tool that you like, is free. Link is in the description below. And if you've got other sort of designs, sort of your go-to for machine stands, I'd love to see them to see what I'm missing out on or not. Thanks for watching.